Hello and welcome to another episode of Problem Solving. Your exams are very near for class 10 students, whichever board you are. I already told you about the combination of resistances. Today I'm going to show you a very simple problem, how to solve it, where EMF, lost volt, combination of resistance, everything is involved. So let's proceed. So now we come to a very simple circuit diagram. As you can see, each and every circuit diagram is kind of different, because you are going to get several different kinds of combinations. First, when you see such a diagram, you have to first understand which all resistances are in series, which all are in parallel. Let me make this clear first. Here we are having a cell with written EMF 4.5 volts and internal resistance 0.5 ohm. Now see, when you are facing this kind of a problem and you find there is a resistance with E mentioned, then always remember that resistance is internal resistance. Okay? Then when we draw the current direction, it will be from the positive to the negative. Okay, it's known to you. Now, when current comes to this point, to this terminal, it sees three paths. As I have explained it to you, that when there is a division of current, that means those resistances are in parallel. Okay, and then the current that divides again gets united, and the main current finally flows through this 8 ohm, comes back. So the main important thing is, here these three are in parallel, the whole combination is in series with 8 ohm, and all of them are in series with the internal resistance. So in this kind of a circuit diagram, when you are asked to find the total current, your first work will be to find the total resistance. So let me make it clear. The EMF here is 4.5 volts. Okay. First you calculate the resistance here. Parallel. They are in parallel. So if I call the equivalent resistance as Rp. So 1 by Rp is 1 by R1 plus 1 by R2 plus 1 by R3. So simply I write it as 1 by 3, 1 by 1.5, 1 by 1. And if you do the LCM, you'll get a very simple result. I'll ask you never to make a step jump. That may actually affect your problem. You may be very confident, yes, I can do it. Confidence is good, but overconfidence is not good. So you get it simplified always. 5 2s are 10, 5 3s are 15. What you get is 1 by 3, 2 by 3 plus 1. Finally, if 3 is the LCM, 1 plus 2 plus 3. So it becomes 6 by 3. And you get 2 by 1. Don't leave it like that. Don't forget, this is 1 by Rp. So Rp is the reciprocal of 2 by 1. So it's 1 by 2. So Rp is finally 0.5 ohm. That means these three together gives you an equivalent resistance of 0.5 ohm. And it is known to you, when resistances are in parallel, those parallel resistances create an equivalent resistance which is even smaller than the smallest of the resistance. Keep that in mind. Here, the resistances which are in parallel are 3 ohm, 1 ohm and 1.5 ohm. And what is the equivalent resistance you are getting for this parallel combination? It's 0.5. So 0.5 is even smaller than 1. So whatever resistances are connected in parallel, The equivalent resistance is smaller than the smallest of the resistance. Keep that in mind. Okay. So let's proceed for the sum. Here RP is being calculated. Now your work is to calculate the total current. Okay. I'm not doing a lot of writing. I'm just trying to make your concept clear. Exam is very near and many students face all these problems in detail or in description, whatever it is. Sometimes it's not clear to them. I'm just trying to help you out. Each and every student always doesn't have the scope to reach out to you can say concept or a very good explanation. So in that case, I think my video will be helpful. If it is helpful to you, please do subscribe and like my channel. And I'm really eager to reach out to many students who really need this kinds of practice, this kinds of clear idea or method to proceed for a sum. Okay, let's come back to RT. RT is resistance here plus 8 ohm plus the internal resistance. Okay, now you have to think that these three have been combined to get 0.5. So 0.5, 8 ohm and 0.5 ohm of internal resistance provides you 9 ohm. Okay, this is the total resistance. Now, if you are asked to find out the total current, so the total current I is what? V by R. Here V is 4.5 volts and R is 9. So what do we get? We get the total current as 0.5 ampere. Okay, total current is 0.5 ampere. Now internal resistance is 0.5 ohm. If you are asked to find the potential drop across the internal resistance, that is lost volt. Lost volt is the total current into internal resistance. Do not forget that. Lost volt is total current into internal resistance. Total current is 0.5 and again internal resistance is 0.5. So what do we get? So this much is lost. You cannot put it to any useful work. This amount of energy is lost across the internal resistance. Okay, so I think this much is clear to you. And after this, I shall discuss with you a very simple thing, okay? We will also discuss video on resistance, you know resistance of a wire. It actually depends on the length of the wire, on the area of cross section of the wire. And how do they depend? Resistance is directly proportional to L and resistance is inversely proportional to area of cross section of the wire. And when we write it together, we need a constant of proportionality, which we term as rho. Rho is nothing but resistivity of the conductor. Main thing to remember is you may change a wire in its length, in its area of cross section, but if you don't change the wire as a material, suppose you take a copper wire, in both the cases where length and area are different, but if it is a copper wire in 2 or 3 cases, this rho will remain constant, because resistivity here is actually the characteristic of the material of the conductor. Okay, so resistivity, it will be constant. We will actually discuss problems on this, and it's very interesting. There are certain questions like that, if you are having a wire of resistance, suppose 6 ohm. You are having a wire of resistance 6 ohm, which is cut into 2 halves. That means 3 ohm and 3 ohm, and then connected in parallel. That is, when you cut a 6 ohm resistance wire into 2 halves, okay? Into 2 halves. So each half becomes 3 ohm, 3 ohm. Now you are asked that now if they are connected in parallel, then the story becomes like this. So you are having one 3 ohm here, and then you are having another 3 ohm here. So this is the combination that it becomes. Now then you are asked to find the equivalent resistance. So is it interesting? So equivalent resistance 1 by Rp will be 1 by 3 plus 1 by 3. What do we get? We get 2 by 3. That is 1 by Rp. Never forget, I have seen students who directly then write Rp equal to 2 by 3. No, Rp is not 2 by 3. When you have a parallel combination, it is 1 by Rp, not Rp. So 1 by Rp is 2 by 3. So do not forget to write Rp by the reciprocal. Okay, it's becoming 3 by 2 ohm. So that is the value of cutting a wire of 6 ohm into 2 halves and putting each half into a parallel combination. Okay, so this needs a lot of practice. I shall tell you to practice all these problems, because in exams you have a very short time. You don't have time to just ponder about. You just need to have a very good practice so that you see the sum, you start doing it. These are the very basic things. I'm going to discuss with you problems on resistance of a wire. Suppose a wire is taken, and then that wire, you are having that wire, and after that you stretch it. Okay, if you stretch the wire, the area of cross section will change. I'm going next in my video, I am going to discuss those problems where you stretch a wire and then find the new resistance. Okay, all those problems are also very important. Okay, thank you. And if you like my explanations, please write in the comment box of your requirements. I shall go through the comments, and accordingly I shall try to help you out just before the exams. Thank you. Please like and subscribe.